Okay, welcome to this video about equations of lines. We're going to be talking about x and y intercepts and how we can use those to graph equations. First of all, let's just try graphing this equation without knowing anything about intercepts. We have 2x plus y equals 6. Well, this is a little bit inconvenient to graph using the t-chart method unless I solve this equation for y. So let's do that first. Let's go ahead and subtract a 2x from both sides, so that I get y equals negative 2x plus 6, okay? And then what I can do is I could plug various x values in, and then I can plug them into the equation and find the matching y values. So that's what I've done here, right? I've plugged in negative 2 into the equation, and out comes a 10, and so that means that negative 2 for x and 10 for y is one of the points that's on this equation. So if I wanted to graph this, I could graph that, at least that one point, by going negative 2, positive 10. There's one of the points on the line. Right? If I plug a negative 1 in, I get an 8 out. Negative 1 is an 8, and so that's here. And I could keep doing that and getting all these points, right? When I plug a 0 in, I get a 6. When I plug a 1 in, I get a 4. Right? 1 is 4. When I plug a 2 in, I get a 2. So 2, 2 is a point on the line, and 3, 0 is a point on the line. Okay, and let's see, 4, negative 2 is a point on the line. Okay, so these are all points that are on this line, and if I wanted to, there's other x values that are between those values, right? And if I were to put points in for all of them, it would form a line that continues forever in both directions, right? Okay, so as we look at this line, right, there's a couple of points that are sort of special. That's where we cross the x-axis, which is the horizontal axis, and the y-axis, which is the vertical axis. So these 2 points here, this point here that's crossing the x-axis is, in this case, it's 3, 0, and it's referred to as the x-intercept. Intercept means to intersect or to touch, or something like an interception in football is when somebody gets in, crosses over the path and catches the ball instead of the intended receiver. So it's where two things come together at the same point. So the x-intercept is wherever the line intersects or touches the x-axis. And then this particular example, it's the point 3 for x, y is 0, 3, 0. And then there's another point here at 0, let's see, 0, 6, which is called the y-intercept, because this is where the line intercepts the y-axis. Okay? So those 2 points are in some way special. But I want you to notice something about the points, right? The y-intercept has a number associated with it, but the x at that point is always 0, right? Wherever the line intersects the y-axis, that always happens when x is 0, right? So for the y-intercept, right, x is always 0. And for the x-intercept, right, because it's crossing the x-axis, the y has to be 0. So that's an important point about intercepts that we're going to use, right? X and y intercepts are points. They have an x-coordinate and a y-coordinate. Okay, so the y-intercept, which in this case was 0, 6, that always occurs when x is 0, right? And the x-intercept always occurs when y is 0. So it has a 0 for its y, and then a number like 3 for its x value. Okay, so 2 points here. Intercepts always occur when the other variable is 0. X-intercept occurs when y equals 0. Y-intercept occurs when x is 0. And the intercepts themselves are points, so they have an x and a y coordinate. Okay, so we can actually find the intercepts of a graph of an equation without graphing it. We can just take advantage of this idea that an intercept always occurs when the other variable is 0. So we can just take the equation, set the other variable equal to 0, and solve the remaining equation. So let's say I want to find the y-intercept. Okay, I can do that. That occurs when x is 0, right? So I'm going to just substitute 0 in for that x. And when I do that, this term with the 0 just goes away, right? I'm left with 0 plus y equals 6, or just y equals 6. And so that means that the y value at the intercept is the 6, right? But that means that I plugged a 0 in for x. So that's how I could find that the y-intercept is 0, 6, right? And I could do the same thing for the x-intercept. If I want to find the x-intercept, that happens when the other variable y is 0. So I would put a 0 in for y in the equation. Just substitute a 0 everywhere there's a y, right? And then solve the remaining equation. 2x equals 6 And let's see, in this case, it turns out x is 3. And so that means when x is 3, y is 0, right? So there's always a 0 for one of the two things, right? For the x-intercept, the y is 0, and for the y-intercept, the x is 0. So that's how we could find without graphing much faster. If we just need to know the intercepts, we can just plug in 0 for the other value. All right, in fact, we use this so often for graphing that we have something that we usually call in the Desert Vista Math department the cover-up method, okay? Because when you plug a 0 in, that term just goes away. You can kind of cover that up. So let me show you how I would solve this again. Let's say I wanted to find the x-intercept, and I know that happens when x is 0. All I'm going to do is I'm going to take my hand, okay? I'm going to take my hand here, and I'm going to just put it over the x term, right? If x is 0, that 2x right there is going to go away. And what I'm left with is the equation y equals 6. And so I can just solve when x is 0, y is 6. So I don't even really write out what happens when I substitute 0. I just literally cover it up with my hand. And the same thing for the x-intercept. If I want to find the x-intercept, the y equals 0 at that point. So I just take my hand and I just cover up the term with y, forcing it to be 0. And what am I left with? I'm left with this equation 2x equals 6, which I can then solve. X equals 3. So when x is 3, y is 0, and that's the that's the x-intercept. Okay? So we call that the cover-up method because we're literally just covering up a piece of the paper with our finger or our hand. Okay? Okay, so we can actually use this to graph lines, right? Here's that, I think it's the same equation again, 2x plus y equals 6. Let's use the cover-up method to find the intercepts, and then we'll use those to graph. Okay, let's find the x-intercept first. The x-intercept happens when y is 0, so I'm just going to cover up the term with the y, and I'm going to solve the resulting equation. 2x equals 6. So x is 3. So that intercept is 3 comma 0. And then I just go ahead and put that point on the graph. If I'm trying to graph from the intercepts, that would be 3 in the x direction, right, and 0 in the y direction. That's that point right there. Okay, and then I can switch to find the y-intercept, which occurs when x is 0, right? And so if I want to do that, I just go back to my equation. This time I'm going to plug 0 in for x, so I'm going to cover up the term with the x, and I'm left with y equals 6. And that means when x is 0, y is 6, there's the second point. 0 comma 6, 1, 2, 3, 4, 5, 6 is right there. So there's the y-intercept. Now here's the thing about lines, right? Because they're straight, as soon as I have 2 points, if I draw a line through those 2 points, I've drawn the entire line. I only need to know 2 points in the line in order to draw it. And so I can just draw the line through those 2 intercept points and I'm done. All right, so actually this is the easiest way of all to graph an equation. Most people think you should solve to put it in slope-intercept form, y equals mx plus b and all that, but actually it's faster to just find the 2 intercepts and draw a line through the 2 intercepts. Okay, so if you feel like you have that idea, try this one. Find the x-intercept and the y-intercept and use it to graph. So pause the video, unpause when you're done. Okay, so here's what you should have done, right? To find the x-intercept, we set y equals 0. Okay, so let's do that. Y equals 0. The y goes away. And let's see, I've got 2x equals 3, or equals 6 is the remaining equation. So if I divide by 2, x equals 3. So when x is 3, y is 0. That's the x-intercept. Okay? For the y-intercept, that's going to happen when x is 0. So let's move our hand over here. Whoops. Get my hand. Okay. Let's make x 0 this time. And so that's going to make this 3y equals x because the 2x is going away. And then if I divide both sides by 3, I get y equals 2. So when x is 0, y is 2. So the 2 points that are on this line are the x-intercept at 3 comma 0 and the y-intercept at 0 comma 2, which would be right here. And so this line looks like that. Okay. So pretty straightforward. Here's another example. Let's try this one as well. Okay, welcome back. So let's try finding the x-intercept when y is 0. So let's see, we're going to make y 0, so the y term goes away. And I'm left with 4x equals 6. Divide by 4, x equals 6 over 4, which I can factor, right? That's the same as, let's see, 2 times 3 divided by 2 times 2. And the 2 and the 2 cancel to a 1. Really, that's a 1. So it's 1 times 3 halves. So that fraction simplifies to 3/2. So when x is 3/2, y is 0. Okay, it's fine that it's a fraction, right? It's not true that every math problem has to have an integer as a result. Certainly fractions or decimals are allowed. So if x is 0, right, we're covering up the x this time, we would have the equation 3y equals 6, and when we divide by 3, that one happens to be an integer. When x is 0, y is 2. So I've got 2 points here. I've got 0, 2, the y-intercept right there. And then 3/2, 0. So what is 3/2? Well, 3/2, let's see, 4/2 would be 2, right? 2/2 would be 1, so it's somewhere between 1 and 2. It's 1.5, right? So I could just graph that as being somewhere between 1 and 2. So I'm going to put a dot here right halfway between 1 and 2, and that's where I draw my line through that. Didn't quite hit that, but you get the idea. It should be going through this point that's halfway between 1 and 2. All right. Okay, how about this one? Graph the line using intercepts. Well, let's see. We've got x-intercept happens when y equals 0. When y equals 0, let's see, the y goes, that's a 0 over there. So we have, so it's not really that it canceled. I guess we're going to have to write it out, that this is 0. 2x minus 5 has to equal 0. So if I plug that in, right, I get 0 there. All right, so I have a little bit more solving to do here in this case. 5 on both sides. 5 equals 2x. When you divide both sides by 2, again, we have a fraction here for the x value. 5/2, 0 is the x-intercept. And the y-intercept would happen when x is 0. Let's try the cover-up thing again. When x is 0, if I cover that up, the 2 times 0 goes away. So I have y equals -5, right, is what's left when I plug a 0 in for x. So 0, -5 is the other point. So 0, -5 would be 1, 2, 3, 4, 5 right down there. There's the y-intercept. And the other one is at 5/2. Well, that's 4/2, which is 2, plus one more half. So it's 2.5. So I'd go over here to 2.5 and put a point. And then the line should go through those 2 points, right? Okay, once we have 2 points, we can draw a line through them. Do all lines have x and y-intercepts? What about this line right here? This has a y-intercept, but it doesn't have an x-intercept. Okay, well, how can we look at this case? Let's look at actually all the different points here. What is the equation of this line? Well, that point right there is 0. Let's see, 1, 2, 3, 4. This is the point 0, 4. And what are some other points on this line? Let's see, 1, 2, 3, 4. This is the point 5, 4. And over here we have the point -2, 4. You know what I notice about this? I notice that all of the y values are 4, and it doesn't matter what the x value is at all, right? If you look at later when we talk about slope and everything, we'll explain this further. But the equation for this one particular line happens to be y equals 4. It's all the places where y is 4, and there's no x at all. So, in fact, not all lines do have x and y intercepts. This one does have a y-intercept, right? It does have a y-intercept. The y-intercept is 0, 4, but it has no x-intercept. Okay, and that's okay. Sometimes lines have no intercepts there. Okay, and you could have the other direction if you have a horizontal line, which if you go to the video on slope, you'll find that this is the equation x is -2, right? This particular line does have an x-intercept, right? The x-intercept would be at -2, 0, but it has no y-intercept. It never does cross the y-axis. So it is possible that there could be missing one of the intercepts. Okay? Could we find the intercepts for more complicated equations, things that weren't lines? I think we can use the same idea. Intercepts always occur when the other variable is 0, so let's try that, right? The y-intercept would happen when x equals 0, so let's try plugging 0 in for x. Well, that is y equals -4, so 0, -4 is indeed a y-intercept, right? The x-intercept would happen wherever y is equal to 0. So if I did that, I'd plug a 0 in here. And let's see, I have 0 equals x squared minus 4. If I were to add 4 to both sides, I'd have x squared equals 4, and there's 2 x values that work for that, 2 or negative 2. So it looks like 2 comma 0 and negative 2 comma 0 could all be, both of those would be x-intercepts. So this particular more complicated curve that's not a line has a y-intercept and 2 x-intercepts.